where does our solar system end? Is it at the orbit of the last planet or somewhere far beyond Pluto's lonely path? Humanity's farthest spacecraft, Voyager 1, ventured into space over 45 years ago, yet even now it hasn't truly left the Sun's domain. How is that possible? In this journey, we'll explore the astonishing scale of our cosmic neighborhood. We'll venture from the familiar planets into the dark outskirts, uncovering how the solar system is vastly larger and more mysterious than you might think. Along the way, we'll use vivid stories and recent discoveries, from intrepid probes to invisible comet swarms, to paint a cinematic picture of our sun's far-reaching realm. Prepare to have your perspective expanded. The solar system is not only stranger but bigger than imagination would lead us to believe. Let's start our journey at the center, our Sun. 8 known planets circle this medium-sized star, along with countless moons, asteroids, and comets. Earth orbits at 1 astronomical unit, AU, from the Sun, about 150 million kilometers, 93 million miles. Even this short distance is huge by human standards. A commercial jet flying non-stop would need roughly 20 years to cover 1 AU, and that's just Earth's backyard. The outermost planet, Neptune, orbits about 30 AU from the Sun, roughly 4.5 billion kilometers away. In fact, Neptune is so distant that sunlight moving at the cosmic speed limit takes over 4 hours to reach it. A spacecraft like Voyager 2 needed 12 years to reach Neptune's vicinity. It flew by in 1989, underscoring the vast gulf between our star and its outer planets. Standing on Neptune, if we could, and gazing sunward, the Sun would appear as a tiny, bright point of light. The scale is mind-boggling. Typical diagrams can't fit all this distance on a page. If we shrink the Sun to the size of a basketball, Earth would be a small bead 25 meters away, and Neptune would be an invisible dot 750 meters, half a mile, from the Sun. Yet even Neptune's orbit is just the beginning. To truly grasp how big the solar system is, we must venture further out, into regions where planetary orbits are only a tiny fraction of the whole story. For decades, many people assumed Pluto was the last outpost of our solar system. Indeed, Pluto orbits about 39 AU from the Sun on average, over 5.8 billion kilometers out. But beyond Neptune's orbit lies the Kuiper Belt, a vast ring of icy debris and dwarf planets extending roughly from 30 to 55 AU from the Sun. This is a frozen frontier of countless small worlds. Pluto itself is one of the larger Kuiper Belt objects, joined by others like Eris, Makemake, and Haumea. In fact, 4 of our officially recognized dwarf planets dwell in the Kuiper Belt, alongside Pluto, and scientists suspect there are many more waiting to be discovered. The Kuiper Belt is like a bigger, colder cousin of the asteroid belt, and it's likely the home of many short-period comets. Every now and then, gravity nudges one of these icy bodies inward to become a sun-grazing comet. Until recently, this distant region was entirely theoretical. In 2015, NASA's New Horizons spacecraft gave us our first close-up look at Pluto, revealing mountains of ice and a surprisingly active surface. Then, on New Year's Day 2019, New Horizons flew past a tiny Kuiper Belt object named Arrokoth, nicknamed Ultima Thule, at about 43 AU from the Sun, that's over 6.4 billion kilometers out. Arrokoth, a snowman-shaped rock a billion miles beyond Pluto, became the farthest object ever visited by a spacecraft. These encounters proved that the solar system's story doesn't stop at Neptune. It continues into the darkness, with strange new worlds at the edge of sunshine. As we continue outward, we enter a realm where distances are measured in light hours instead of kilometers. Out here, something remarkable happens. We approach the boundary of the Heliosphere, the giant bubble of charged particles and magnetic fields the Sun blows around itself. For most of its life, our Sun has been firing a stream of high-speed particles, the solar wind, in all directions. This wind inflates an enormous bubble in space that encompasses all the planets. But even the solar wind has limits. Eventually, it collides with the interstellar medium, the sparse gas between the stars, and slows down. The point where the solar wind abruptly slows from supersonic speeds is called the termination shock, found around 80-90 AU from the Sun. Beyond that, is the Heliosheath, a turbulent region of mixed solar and interstellar particles. Finally, at roughly 120 AU from the Sun on average, the solar wind S pressure is no longer strong enough to push back the galaxy S gas. This is the Heliopause, the outer boundary of the Heliosphere, and the beginning of interstellar space. In 2012, Voyager 1 became the first spacecraft to cross the Heliopause at about 121 AU from the Sun. Its instruments detected a sudden drop in solar particles and a rise in cosmic rays from outside the solar system, clear signs it had entered interstellar space. Voyager 2 followed, crossing into interstellar space in late 2018 at roughly 119 AU. For the first time, we had direct samples of what lies outside the Sun's magnetic bubble. These venerable probes, launched in 1977, confirmed that the Sun's influence has a measurable edge, a frontier where our star's environment gives way to the wider galaxy. It is awe-inspiring to realize that the Voyagers traveled over 18 billion kilometers to reach this boundary. And yet, in another sense, the solar system still hasn't ended. Why do we say that? Because gravity is the glue that truly binds a solar system, and the Sun's gravitational pull extends much farther out than its heliosphere. To find the ultimate limit of the solar system, we must follow the Sun's gravity to its farthest holdouts, the realm of the Oort Cloud, far beyond the orbits of the planets, beyond Pluto, beyond the Kuiper Belt, and even beyond Voyager's current reach. Astronomers infer the existence of a colossal reservoir of comets encircling the Sun. This is the Oort Cloud, a spherical cloud of countless icy bodies orbiting at the fringes of the Sun's gravity. No telescope has yet seen the Oort Cloud directly. Its objects are too small and distant, but we see clues of its presence whenever a long-period comet swings into the inner solar system. These comets, with orbits lasting thousands or even millions of years, likely originate from this distant cloud, knocked loose by a gentle tug from a passing star or the Milky Way's tidal forces. How far away is the Oort Cloud? By current consensus, the inner edge of this cloud might begin around 5,000 AU from the Sun. In other words, the Sun's gravitational influence could extend up to nearly 100,000 times farther than Earth's orbit. This distance is so immense it defies easy visualization. 100,000 AU is roughly 1.5 light-years, about one-third of the way to the nearest star system, Alpha Centauri. If those numbers sound abstract, consider this vivid analogy. If the Sun were a basketball sitting in Miami, Florida, the Earth would orbit at about 1 meter away, a tiny bead. Neptune would circle at roughly 750 meters, half a mile away. But the Oort Cloud's outer edge would be a shell with a radius of 2,500 kilometers. That's about the distance from Miami to Portland, Maine on a map. In this model, our solar system's invisible boundary would span the entire eastern United States. In reality, it spans about 3 light-years across, encompassing an unknown multitude of frozen comets. Out there in the Oort Cloud, the Sun's warmth is almost non-existent. An object would see the Sun as just a particularly bright star in a black sky. These comets are in deep freeze, preserved since the birth of the solar system. Occasionally, a gravitational nudge, perhaps from a passing star eons ago, will perturb an Oort Cloud comet, sending it on a long fall toward the Sun. When we marvel at a great comet in our sky, we were witnessing a visitor that may have spent millions of years in the outer darkness before its moment of illumination. The Oort Cloud, therefore, is like a cosmic time capsule, a repository of primordial material, and an archive of our solar system S formation, scattered at the edge of interstellar space. Crucially, the outer limit of the Oort Cloud effectively marks the boundary of our solar system. Beyond 100,000 AU, the Sun's hold-on objects become so weak that the gravity of other stars and the galaxy can steal them away. In fact, the cosmographic boundary of the solar system is defined here, where the Sun's gravitational influence gives way to that of passing stars. Our solar system likely intertwines with those of other stars at these distances. A fascinating thought. It means there isn't a hard shell where the solar system ends, but rather a gradual blending into the gravitational landscape of the Milky Way. Every so often, another star may wander relatively close and disturb our Oort Cloud, or one of our comets might be ejected to roam free among the stars. Likewise, we've detected interstellar interlopers, like the cigar-shaped object Oumuamua in 2017, that entered our inner solar system from elsewhere. This suggests that star systems can exchange small bodies, trading cosmic messengers across the light years. Now pause to absorb this scale. The majority of our solar system ES radius is taken up by this dark, distant cloud. By volume, the region of the 8 planets is a tiny fraction of the solar system. Most of our sun's realm is empty space with a sparse scattering of frozen rocks. The Voyager 1 probe, humanity's farthest envoy, at 160 AU today, is barely 0.2% of the way to the Oort Cloud's outer edge. In fact, NASA estimates Voyager 1 will take 300 years just to reach the inner Oort Cloud, and may need 30,000 years to fly beyond it entirely. This stark fact truly drives home how enormous the solar system is, and how slowly even our fastest ships move relative to those vast distances. It may astonish you that even now we haven't mapped everything orbiting our sun. The solar system's immensity leaves plenty of room for mysteries. One of the biggest: could there be an unknown planet lurking out in the deep frontier? In recent years, astronomers have noticed peculiar clustering in the orbits of distant Kuiper Belt objects like Sedna. These orbits might be shepherded by an unseen massive planet far beyond Neptune, a hypothetical world popularly dubbed Planet 9. If it exists, Planet 9 could be perhaps 5 or 10 times the mass of Earth and orbit hundreds of AU from the Sun. Models suggest an average distance on the order of 400–600 AU, around 1,000 times farther out than Pluto's Sun distance, taking an incredible 10,000+ years to complete one orbit. Astronomers Konstantin Batygin and Mike Brown proposed this idea in 2016, and since then multiple studies have bolstered the case with more data. As of 2025, Planet 9 remains unseen, but new sky surveys are underway, and even NASA SY's Space Telescope data and others have been combed for hints of a distant moving dot. If and when we finally detect this world, it will re-emphasize how little we truly know about our own solar system's far reaches. The very possibility of a hidden planet in our Sun-S family underscores that the solar system S story still holds surprises. Meanwhile, the Voyager probes keep sending back data, albeit faintly, as their power dwindles, from beyond 150 AU, giving us our first direct taste of interstellar conditions. New Horizons continues to journey through the Kuiper Belt, measuring the environment of the outer Heliosphere and perhaps aiming for another Kuiper Belt object if one can be found in its path. Future missions are being dreamed up to venture into the Oort Cloud or even beyond. Proposals like an interstellar probe that could reach 1,000 AU in a few decades. These missions would attempt to explore the uncharted territory at the solar system's edge, examining the fossil radiation from the Big Bang, less obscured out there, sampling interstellar dust, and perhaps directly observing Oort Cloud objects for the first time. Humanity stands on the shore of an immense cosmic ocean, preparing at last to set sail into the truly unknown. Looking back at our journey, it is clear that solar system means so much more than the 8 planets we learn in school. It is a vast architecture: planets, rings, belts, clouds, and voids, all bound by the gravity of our Sun. We began at Earth, where the Sun's warmth feels immediate, and traveled outward in our minds past the giant planets, into the Kuiper Belt's twilight through the Sun's protective bubble, and finally to the silent frozen comet cloud, nearly a light-year away. By any human measure, these distances are virtually incomprehensible. We rely on analogies: a basketball sun, a pale blue dot, a journey from Miami to Maine, to even hint at the scale. Emotionally, the realization of this immensity can be profound. It reminds us of the pale blue dot perspective, that our entire world is a tiny, fragile speck in an enormous darkness. But it also sparks awe. Our sun, one ordinary star among billions, rules a kingdom of such grand extent that it takes light years to traverse. Finally, consider this: even our gigantic solar system is just a pinpoint in the Milky Way galaxy. The nearest stars have their own vast comet clouds likely overlapping with ours at the edges, Our sun's family of planets and far-flung debris is one drop in a cosmic sea. Yet, for us, it is home. The ongoing exploration of this home, from Mercury's scorched surface to the distant whisper of Voyager 1, is a story of extending our reach and understanding. It's a tale that blends science and imagination, showing how curiosity can push back the frontiers of the unknown. Standing under the night sky, you might gaze up and ponder where the solar system ends. The truthful answer is both mind-expanding and poetic. It doesn't have a sharp edge, does it? Just fades into the stars. Our sun's influence stretches across an almost unfathomable expanse, and beyond that, the influences of other suns begin. In that enormous expanse lie countless pieces of the puzzle that is our origin and destiny. The solar system is larger than you think, and that realization leaves us humbled, yet also filled with wonder. As we continue to explore and learn, we are continually reminded that the grandeur and mystery of our cosmic neighborhood far exceed the boundaries of what we once assumed, inviting us to keep discovering what lies in the dark reaches beyond. In the end, the more we uncover, the more we stand in awe of our sun's vast empire and the tiny blue world we call our own within it. As we drift outward from our tiny world into the vast expanse of the solar system and beyond, we're reminded of how much there still is to discover. Each layer, from planets to comets to distant clouds of ice, tells a deeper story about where we come from and where we might go. If this journey sparked your curiosity, imagine what lies ahead. From hidden planets and interstellar messengers to missions that may one day pierce the edge of the Oort Cloud, this is just the beginning. Subscribe to our channel to keep exploring the frontiers of space with us. We break down the cosmos one story at a time, no rocket science degree required. Stay curious, stay inspired, and remember, the solar system is far bigger than you think, and the universe even more so. Hit subscribe, tap the bell, and join us for the next journey into the unknown. Thanks for watching.